bigger than a football field, heavier than 100 Boeing 747s stacked together, more powerful than a fleet of Formula One cars. These are not science fiction creations or movie props. These are real machines, built by human hands, operating right now somewhere on this planet. When you see a construction crane lifting steel beams downtown, you might think that is impressive. But what if I told you there are machines so massive they make that crane look like a toy? Machines that eat through mountains, move rockets to launch pads, and reshape entire landscapes in a matter of hours. Today, we are going on a journey through the world of industrial giants. Machines so absurd in their scale that even the engineers who designed them sometimes shake their heads in disbelief. From German coal fields to American space centers, from frozen Siberian mines to underground tunnels beneath major cities. Get ready to witness engineering taken to its absolute extreme. Let me start by painting a picture for you. Imagine standing in an open-pit coal mine in Germany. The air smells of diesel and earth. The ground shakes beneath your feet with a rhythm that feels almost alive. A low rumble fills the air, growing louder with each passing second. You look up, and your brain struggles to process what your eyes are seeing. Rising before you is a machine taller than the Statue of Liberty, longer than 2 football fields placed end to end. This is the Bagger 293. The ground trembles as it moves, powered by enough electricity to supply a small city. Built by Tokraf in 1995, the Bagger 293 officially holds the Guinness World Record as both the largest land vehicle and the heaviest land vehicle ever built. At 96 meters tall and 225 meters long, it weighs an almost incomprehensible 14,200 metric tons. That is roughly equivalent to the weight of 2,400 elephants standing on top of each other. I find it incredible that humans could even conceive of building something this large, let alone actually construct it and make it work. The bucket wheel itself is over 21 meters in diameter, spinning continuously with 18 buckets that can each hold over 15 cubic meters of material. Every single day, this machine moves 240,000 cubic meters of earth. To put that in perspective, that is enough material to fill 96 Olympic swimming pools every 24 hours. The operators sit in a cabin dozens of meters above the ground, with a view that stretches for kilometers across the mining landscape. It takes 5 of them working in perfect coordination to control this beast, communicating constantly through radio systems as they guide its movements across the mining pit. The Bagger 293 does not run on diesel or batteries. It draws 16.56 megawatts of external electrical power, fed through massive cables that snake across the landscape behind it, like metal umbilical cords connecting this giant to the power grid. The maintenance teams work around the clock. With thousands of moving parts, bearings, motors, and hydraulic systems, something always needs attention. But the Bagger keeps working, year after year, moving more earth in a week than most excavators move in a lifetime. I don't know about you guys, but I can't even process 14,000 tons in my head. To me, it's like that number doesn't even exist, let alone that we can actually measure it. But while I was researching the Bagger 293, what struck me most was how we humans are so tiny compared to it. Yet we took thousands of years of accumulated knowledge and just went out there and built this thing to serve our society. It's wild to think about that power to process information and actually make something happen. It's a mix of pride and a slight sense of dread and anxiety, not knowing what else we might be capable of creating. I keep imagining the first engineer who actually designed and executed this. Was he confident everything would work out? I'm sure there were countless mistakes along the way. Did he just burn out? It's a project that almost defies the laws of nature. When I look at that structure, I don't just see metal. I see our sheer stubbornness in shaping the earth to our will. Seeing the Bagger isn't like seeing a car or a truck. It's like seeing a mountain that learned how to walk. And to be honest, that scares me sometimes. Let me know in the comments if you agree with me, or if I'm just going crazy thinking about this. But if you think the Bagger is impressive, wait until you see what the Germans built just a few kilometers away. The F-60 overburden conveyor bridge is not just a machine. It is a mobile industrial city made entirely of steel. Stretching an almost unbelievable 502 meters in length, the F-60 is officially the largest movable technical industrial machine on Earth. To understand just how massive that is, the Eiffel Tower is 330 meters tall. The F-60 is 182 meters longer than the Eiffel Tower laid on its side. Let that comparison sink in for a moment. If you put the Eiffel Tower flat on the ground and parked it next to the F-60, you would still need another 182 meters of something to match the length of this machine. Standing 80 meters high with a width of 204 meters, this steel giant weighs 11,000 tons, even after some components were removed. The F-60 was built by VEB Tackraft Lochhammer between 1989 and 1991, just as the Berlin Wall was falling and East Germany was transitioning to a new era. There is something symbolic about that timing. A machine built at the end of one world, now standing as a monument to an industrial age that has largely passed. Its purpose was to remove the overburden, the layers of earth sitting above coal deposits, and transport it away from the mining area using a massive conveyor belt system integrated into its structure. What makes the F-60 truly remarkable is that despite its enormous size, it can actually move. Slowly, yes. But this 11,000-ton structure can reposition itself within the mining pit as operations require. Watching it move is an almost surreal experience. The ground shakes. The steel creaks and groans like a living thing waking from sleep. And this behemoth of engineering crawls forward like some kind of mechanical giant from a science fiction film. The operators who controlled it described the experience as both terrifying and exhilarating. Today, only one F-60 remains operational as a tourist attraction, allowing visitors to walk along its length and experience its scale firsthand. I bet most visitors leave with a new appreciation for what human engineering can accomplish. You know what really leaves me stunned and thinking about the F-60? It's not just its size. Though the fact that it's longer than the Eiffel Tower lying down is hard to wrap my head around, it's the fact that it was built in a world that was already on the brink of collapse. When I look at this incredible machine, I don't just see mining equipment, I see a time capsule. It's as if East Germany poured all of its industrial might into it just to prove they were bigger than West Germany and everything it represented. There's a certain melancholy to it, don't you think? Today, it's just a tourist attraction. It's basically just for show now. Seeing a structure this massive with no real purpose anymore makes me realize how fleeting our greatest technological achievements can be. Yesterday, it was the pinnacle of progress. Today, it's a machine most people don't really care about. It makes me wonder, what are we building today that our kids will look at and laugh at 30 years from now? Now, I want to take you across the Atlantic Ocean to a machine with a completely different purpose. At NASA's Kennedy Space Center in Florida, there exists a vehicle that has been moving American dreams into space for over half a century. The Crawler Transporter. This is not just any piece of industrial equipment. This is the machine that carried every Apollo mission to its launch pad, every space shuttle, and now, the Artemis rockets that will return humans to the moon. There are actually two of them, designated CT-1 and CT-2, and they have been hauling America's largest rockets out to their launch pads since 1965. That is nearly 60 years of service, making them some of the longest operating pieces of heavy machinery in American history. Crawler Transporter 2 was recently retrofitted to handle the new Artemis rockets, and it now weighs 6.65 million pounds, making it even heavier than its sibling. Think about that for a moment. 6.65 million pounds. That is more than 3,000 metric tons of steel, motors, and engineering genius, designed for one purpose: to carry the most advanced spacecraft ever built on a 4.3-mile journey from the vehicle assembly building to the launch pad. And here is the thing that blows my mind every time I research this machine. This 4.3-mile trip takes anywhere from 8 to 12 hours. You could walk faster. A casual stroll would get you there in about an hour and a half. But when you are carrying billions of dollars worth of rocket and payload, slow and steady is exactly what you need. The crawler moves at a maximum speed of about 1 mile per hour when loaded. It runs on massive tank treads, each link weighing about a ton on its own. The entire platform must remain perfectly level during the journey, adjusting constantly for changes in terrain. Any tilt could damage the rocket's delicate systems, potentially ending a mission before it even begins. The operators sit in cabs at each corner of the platform, coordinating their movements with precision that would make a Swiss watchmaker jealous. Let me shift gears now and take you to the former Soviet Republic of Belarus, where the world's largest mining truck calls home. The Belaz 75720 is not just big, it is absurdly, ridiculously, almost offensively large. When you first see one in person, your brain refuses to accept what your eyes are telling it. With a payload capacity of 450 metric tons, this truck can carry more weight in a single trip than most buildings weigh. Think about your house. Now imagine a truck that could pick up your entire house and haul it away like it was a load of groceries. That gives you a sense of what this machine can do. When fully loaded, the Belaz 75710 tips the scales at 810 metric tons. That is the gross weight of about 600 average cars combined into one vehicle. Standing 8.16 meters tall and stretching 20.6 meters long, this yellow behemoth is powered by two 16-cylinder MTU diesel engines, producing a combined 4,600 horsepower. You might be wondering why anyone would need a truck this large. The answer lies in simple economics. In massive open-pit mines, every trip a truck makes costs money: fuel, driver time, tire wear, maintenance. By building trucks that can carry 450 tons instead of 100 tons, mining companies can move the same amount of material with fewer trips, fewer drivers, and ultimately lower costs per ton of material moved. The tires alone on this truck are engineering marvels. 8 massive Michelin tubeless pneumatic tires, each one costing more than a luxury car and lasting for only about 30,000 kilometers before needing replacement. The Belaz burns roughly 1,300 liters of diesel per 100 kilometers. Yes, you read that correctly. Your car might use 8 liters per 100 kilometers on a highway. This truck uses 1,300. That is about 160 times more fuel than a typical passenger vehicle. But when you are hauling 450 tons of rock and ore from the bottom of a pit mine, that fuel consumption suddenly makes economic sense. The truck costs over $6 million, but mining companies line up to buy them because the payback period is remarkably short when you are moving that much material that efficiently. Now, there is something poetic about the next machine on our journey, the Liebherr LTM 11-1200 9.1. While the machines we have discussed so far are about moving earth or rockets in bulk, this crane is about precision and vertical reach. It is the world's most powerful mobile crane, capable of lifting 1,200 metric tons and reaching heights of 188 meters with its telescopic boom system. What makes this crane truly special is its boom. At 100 meters when fully extended, it is the longest telescopic boom in the world, mounted on a vehicle that can actually drive on public roads. Well, mostly. The 9-axle chassis with active rear-axle steering allows the crane to travel to job sites, though it often requires special permits, police escorts, and careful route planning to avoid bridges and overpasses that cannot handle its weight. The LTM 11-1200 9.1 has found its primary use in wind turbine installation. As wind turbines grow taller and heavier with each new generation, the cranes needed to install them must grow as well. Traditional lattice boom cranes take days or even weeks to assemble at a job site. The Liebherr's telescopic boom can be deployed in hours, making it incredibly valuable for wind farm developers working on tight schedules in remote locations where every day counts. The operators of these cranes undergo extensive training. Controlling 1,200 tons at the end of a 100-meter boom requires precision measured in centimeters. A slight miscalculation, a gust of wind at the wrong moment, and disaster could follow. But in the hands of a skilled operator, this crane can place wind turbine components with surgical accuracy. Now just imagine the scene. You're up there, controlling a piece of equipment that weighs way more than dozens of cars, dangling nearly 200 meters in the air. The wind is picking up. You start to feel the structure creaking. Honestly, I'd be terrified. I truly admire anyone who does this for a living, because I'm deathly afraid of heights. Leave a comment below. Am I the only one who feels this way? And for me, that's not even the worst part. It's the pressure of knowing that a single second of distraction could cost millions of dollars, or, even worse, take someone's life. To me, what makes this crane incredible isn't just Liebherr's hydraulics or the steel. It's the human being behind it all. It's a constant duel between gravity and patience. I feel a mix of respect and a bit of agony just imagining the scene. It must be such a lonely job too, on top of all that responsibility. Sometimes we forget that behind all this cutting-edge technology, there's a person right there, sweating bullets and doing everything they can to make sure nothing goes wrong. To me, that's what real engineering is, the control that masters the chaos that's always lurking. I need to tell you about a machine that no longer exists, but left an indelible mark on industrial history. Big Musky was the largest dragline excavator ever built, and it operated in southeastern Ohio from 1969 to 1991. Standing 22 stories tall and weighing 13,500 short tons, Big Musky was a steel giant that moved mountains. Literally. Its bucket, the massive scoop at the end of its boom, could hold 220 cubic yards of material and lift 325 metric tons in a single pass. Think about that. 325 metric tons picked up and moved in one scoop. It would take a fleet of standard dump trucks to haul what Big Musky could grab in a single bite. During 22 years of operation, Big Musky removed more than 608 million cubic yards of overburden. Here is a comparison that might help you understand that number. The construction of the Panama Canal, one of the greatest engineering achievements in human history, moved approximately 300 million cubic yards of material. Big Musky moved twice that amount. One machine, working in a coal mine in Ohio, moved more material than the tens of thousands of workers who spent decades building the canal that connected two oceans. It took 14,000 to 18,000 kilowatts per hour just to run the electric motors that powered Big Musky, producing up to 52,500 horsepower. Big Musky was decommissioned in 1991 when changes in environmental regulations made its operation no longer viable. It sat idle for 8 years before being dismantled in 1999. Today, only its massive bucket remains, preserved as a monument to the miners and engineers of southeastern Ohio. Standing next to that bucket, which weighs 230 tons empty, you can almost feel the presence of the machine it once belonged to. Our journey underground now takes us to Seattle, Washington, and a machine named Bertha. Bertha was a tunnel boring machine that carved its way beneath downtown Seattle to create a highway tunnel, replacing an aging viaduct. Bertha was the world's largest earth pressure-balanced tunnel boring machine, with a cutting head 17.5 meters in diameter. To put that in perspective, a typical subway tunnel might use a boring machine around 6 meters in diameter. Bertha was nearly 3 times that size. The machine stretched 99 meters in length and weighed 6,700 short tons. It was built by Hitachi Zosen in Osaka, Japan, specifically for the Washington State Department of Transportation's Alaskan Way Viaduct Replacement Project. Named after Bertha Knight Landis, Seattle's first and only female mayor, this machine represented the cutting edge of tunnel boring technology. Bertha's job was to bore a 2.8-kilometer tunnel beneath downtown Seattle, passing under historic buildings, the waterfront, and existing infrastructure without causing damage above. The project did not go smoothly. In December 2013, about 330 meters into the planned route, Bertha hit an unexpected obstacle, a steel pipe left over from a previous water well project that nobody knew was there, and stopped. What followed was a 2-year repair process that required workers to dig a 37-meter deep access pit just to reach the machine's damaged components. The delays cost hundreds of millions of dollars and became a major political issue in Washington state. But Bertha eventually completed her mission. The finished tunnel opened to traffic in February 2019, and the machine itself was disassembled and removed piece by piece, its legacy forever carved into the bedrock beneath Seattle. There is a machine I have saved for this moment that perfectly bridges the worlds of construction and raw power. The Komatsu D575A Superdozer is the world's largest production bulldozer, and watching it work is like watching a force of nature with a steering wheel. Weighing 150-600 kilograms when fully equipped, this bulldozer is powered by an 1,150 horsepower engine that produces enough thrust to push through almost anything. The blade on the Superdozer model stands 3.6 meters tall and stretches 7.4 meters wide. In a single pass, it can move 96 cubic meters of material, roughly equivalent to filling a standard shipping container with earth. The D575A was designed for one environment: large-scale mining operations where smaller bulldozers would simply be overwhelmed by the volume of material that needs moving. A normal bulldozer might work for hours to accomplish what the D575A does in minutes. The ground pressure from this machine is carefully distributed across its massive tracks to prevent it from sinking into soft ground, though the earth still trembles with every pass. Operators describe working in the D575A as being inside a controlled earthquake, everything shaking as thousands of horsepower push tons of material aside like it weighs nothing. Every one of these machines has a story. Engineers who dreamed big and refused to accept that something was impossible. Operators who trusted their lives to thousands of tons of steel and motors. Manufacturing teams who figured out how to build components so large they required special transportation just to reach the assembly site. And challenges that seemed unsolvable until someone looked at them from a different angle and said, maybe we just need to build something bigger. What strikes me most about these industrial giants is not just their size. It is the human ingenuity they represent. Every bolt, every weld, every electrical connection was designed by someone, assembled by someone, tested by someone, and operated by someone. Behind every machine is a team of humans who made it possible. This channel is for people who appreciate engineering at its most extreme. If that is you, join us. Subscribe and become part of this crew. We go where other channels do not dare to go. We find the machines that most people have never heard of, and we tell their stories with the detail and respect they deserve. Which of these industrial giants impressed you the most? Was it the Bagger 293 and its city-powering electricity consumption? The F-60 and its absurd length? The crawler transporters carrying dreams to the stars? Let me know in the comments. And if you know of a massive machine that I should cover in a future video, tell me about it. This channel is built on what you want to see. These machines will continue operating long after we are gone. Still moving Earth, still lifting impossible weights, still boring through mountains, still proving that when it comes to engineering, there really are no limits. Only challenges waiting to be overcome by people bold enough to attempt them. Thanks for joining me on this journey through the world of industrial giants. Until next time, keep looking up at those massive machines. They are monuments to what humans can achieve when we refuse to think small.